Good afternoon, everyone. This is Sadia Zafar from HRAI. I would like to welcome you to today's session on incorporating geothermal solutions in your contracting business. Our presenters, Jeff Hunter, President of Evolve Thermal Energy, and Ron Wright, Regional Sales Manager of Enertech, will talk to you about how heat pumps have been used in space conditioning and water heating systems. Also, they're going to talk to you about how ground source heat pumps play a critical role in the building sector's decarbonization. A little bit of housekeeping. You will notice on the control panel of your screen the Q&A feature. Please use the Q&A feature to ask your questions at any time during the webinar. They will be addressed at the end of the session. Also note, this webinar is being recorded and the recording will be sent to you following the session. Now we welcome Jeff.
Thank you, Sadia. Can you hear me?
Yes, we can.
Perfect. Okay, well, welcome everybody. Thank you for joining us today. I see we have quite a diverse group of registrants today, so hopefully we're able to cover off what everybody is looking for. We're going to be pretty broad today. This is sort of a 101 for perhaps contractors that have been hearing about geothermal that are not involved in it yet today and wanting to learn a little bit more. So if there's something that we're not covering that you are interested in, I think our contact details and all of that will be available at the end of the presentation. And so we're happy to answer any questions. And then I think we are taking questions at the end and Loretta's fielding that. So we've got about 40 or 45 minutes of content here, and then we'll get to questions. So just a brief agenda, talk a little bit what the problem is or what our challenge is, electrification and some of the opportunities here. And for those that are new, geothermal, how it works, just a basic overview. We have some performance data from an actual running application, just to give you an idea of field performance. And then for contractors that are considering about getting into geothermal, we're going to take a look at some of the typical equipment options and tools of the trade. Just quickly, we'll identify some of the trends and major opportunities we're seeing right now in geothermal, so low-hanging fruit opportunities. We're going to discuss different types of heat pumps and look at the state of the union as far as the Canadian market goes, and then take a look at another jurisdiction globally that has gone through quite an adoption of heat pumps. So we're just going to take a quick look at Sweden. So right into it, the video's playing already. So this is a video that popped up on my Facebook this winter. This was Edmonton, I think in February, they hit -40 or so. And you can see very clearly, obviously, the vapor is condensing in the air there from all of the space conditioning fuel-fired systems there. And obviously that we're seeing it very visually here because of the temperature and the dew point and all that. And I found another great shot of the outside of the town of the same shot. So, I mean, that problem, just because it's that cold, that's problem one. How do we address that? And I think geothermal gives us a good opportunity to address this. But the hidden problem here, problem number two, is up here in this green box. Interesting. So this was, we all saw out west, I think they called it the heat dome a few weeks ago. And so the same town, Edmonton, was somewhere around +40 Celsius in June. So a 4-month spread, you've got an 80-degree temperature difference. So it's pretty extreme. So one of the hidden problem here is that when we're using systems to air source heat pump systems to try and generate heat out of -40 degrees C and then try to reject heat in +40 degrees C, that causes some interesting challenges that need to be addressed. And this was talked quite a bit. If you've been following along with what the information that the OGA has been putting out in HRAI, there's been a number of studies done in the last couple of years, and the first one was by ICF for the Canadian Gas Association, and it was released in the fall of 2019, and it basically came out with, well, among other things, cost estimates for electrification, indicating that certainly it's a massive feat, and the costs are going to be there, but they came out with a cost of somewhere around $1.4 trillion to electrify space conditioning in Canada, which is a tremendous number. And unfortunately, the study did not assess the impact of ground source heat pumps on that cost. And so we really felt that, and HREI really felt that that's something that needs to be added in there and assessed. And so that's why HREI worked with Dunsky Energy Consulting to come up with the first study, which was released in October of 2020, a year later, which adds in that value. And now looking through that study, you can see the impact, which is based on ICF's original model and their original information. So the impact of ground source heat pumps can be pretty substantial, based on their numbers, up to half a $1 trillion of an impact. So very substantial there. So from there, they took the next step to say, okay, well, and this was just released in the last couple of months, about a month ago, actually, so what policies can work in Canada to help with the adoption of ground source heat pumps, and what has worked in different jurisdictions across the world. So we kind of put that together, and that came out in June. So if you're looking for to go in detail on those reports are available on HREI's website. So essentially, though, where this impact comes from is by utilizing thermal energy that's available at point of use at every building, beneath your feet, wherever you are. So geothermal energy is essentially solar energy that's absorbed by the earth. The earth itself is the world's largest solar panel. So we want to try and harness and use that energy. And that's what we're doing with ground source heat pump systems. You can see on the right here, a bit of a chart here that shows temperature of the earth based on depth. And you don't have to go down very deep at all to access a stable or relatively stable energy source. So that energy is there free for us to use all year. And with geothermal systems, we access that energy in different ways, and it's kind of evolving a little bit or expanding in the last little while. But typically, we have a couple of different applications here. Vertical systems, where we're using specialized drilling equipment or water well drilling equipment, or more specialized equipment, depending on the application, drilling down vertically, boreholes, and installing closed piping in those borehole systems. The next application here is more typical in cottage country areas, residential areas next to water. Great applications is putting piping networks right into lakes and ponds and surface bodies of surface water. Great application for getting heat from. Over on the right here is more conducive to rural applications. So we've got the piping network laid out horizontally and typically buried just beneath the frost line. So that's typically used where you have a fair amount of room. Now, in more recent times, in this geo-micro district, this terminology comes out of New England, the heat group there that's been doing a lot of work with utilities in the New York State and New England area, essentially a district, micro district energy system for geothermal, a low carbon district energy system. So this particular picture was an original photo from an application that's actually underway right now in the Markham area. I believe it's a Mattamy Homes development, where they're experimenting with this type of system there, utilizing boreholes installed in utility rights of way and connecting homes and buildings onto common loops. And certainly there's benefits to connecting buildings of different types onto common loops, as they provide a bit of diversity in the loads and sharing of thermal energy and sharing of thermal mass. And so there's a bunch of benefits there to connecting them into a common system. But another one is emerging with a lot of strength these days is wastewater heat recovery. I mean, there's a lot of energy in our wastewater. So anyways, and then wastewater in larger applications certainly is predictable loads. And so we can reuse that heat in different applications. And that's really it with the geothermal, is understanding different sinks and sources of heat and how we can move that energy through these different systems. Now, Ron, just I'm going to hand this one over to you to take on the next few slides and just give a bit of an explainer of the process.
Okay, thank you, Jeff. Thank you, everybody, also for taking time out of your busy schedules today and for taking in this. But yeah, Jeff mentioned that the ground is a great method of heat transfer. But looking at some of the numbers there at the bottom, you can see that for every dollar you spend for a watt of energy from the grid, different units will give you different COPs, but you can get 2 to 4 up to 5 times worth of energy out of the ground in return. So you can see it is the best means for providing heating and cooling, domestic hot water that's available. And Jeff talked about the loops a little bit, and there is no best way to put a loop in, but as far as designing a loop, whether it's vertical or horizontal, so long as they're sized correctly, both will do a fantastic job in your space, whether that be residential or commercial agriculture. But that is very key to a good geothermal system is the loop that's in the ground. And as mentioned there at the bottom, these will do heating and air conditioning. So you get the benefits of both out of that same unit, the same loop, and so on. So, but the energy from the sun helps drive the bus on this for us. Okay, next slide. And here you can see some actual loops going in the ground. And again, it's key and critical. This one is depicting a horizontal loop system. Proper footage of pipe in the ground is very key. There is different programs available from different manufacturers to help with this. A lot of dealers have access to this type of information for you. So as far as, like in this case, it's showing a horizontal loop system. So, on average, you're looking at probably 6 to 8 feet in the ground, pipes spaced about 2 feet apart for best heat transfer from the soil to the loop in the ground, filled with the water and ethanol or glycol or what have you, whatever's used. So, but if you've got a good adequate land availability, a horizontal loop system is a great way to do that if you've got that land availability. The vertical loop system, which is the next one, utilizes, oh, sorry, Jeff, go ahead.
So I just want to chime in here. I mean, this is sort of a couple of these pictures here are showing really ideal greenfield applications where we have lots of room and, basically just go and dig a trench out that way and put your pipe in the ground. And it doesn't always, of course, happen that way. And these types of systems can be structured to fit into smaller areas. It just takes a little bit of working it around. And I do want to say that we're not really showing here some of the applications today of horizontal directional drilling. I think there may be some folks on the call here. I'm thinking of Buchanan and Hall and Stratford, who operate a fleet of directional drilling rigs that's able to do this type of application without disturbing or disrupting the surface. And so that can be very beneficial in some applications, and the costs of it are not as expensive as a vertical application. Somewhere in between horizontal trenched and vertical, you'll find horizontally directionally drilled system. So this is just showing a couple of examples, but certainly it changes in many different ways.
Very good point, Jeff. And to the point of the directional bore, a lot of properties that we've seen are very well manicured, and they don't want to disrupt a lot of their acreage or their land that their house is on. So you've got beautifully sodded or seeded grass, and it's well looked after. This one, you're available to make a little bit more of a mess per se, and then put it back into its condition before. But yes, directional bore is a great option. A little bit more money, but this one depicts some lake loops, and again, when they're designed right, and the pipe spacing is key with these type of systems. So if there's a lake or a pond that you're allowed to use, whether it's on your property or in some jurisdictions, lake loops are not allowed, but in some cases they are. So this is another great means to do that if you don't have the land ability, but you do have a body of water that you can use. You just have to make sure you've got a good consistent depth of water there year round, because as seasons change, depths of water can change as well, and that can have a direct impact on the efficiency of the loop. So you've got to make sure that you've got that depth of water all the time, year round.
I think it's interesting here in this top left one. I don't know, can you see my mouse on the screen? Is that showing?
Yes.
Okay, so the top left picture there was interesting innovations from contractors as they got busy installing lake loops. They would prefabricate loops in their shop and then find interesting ways to get them to site, because not always do you have room on site to install different types of loops. As you can see in this situation, the contractor went with a series type application because the shoreline is pretty much non-existent to be able to build a nice big mat like you have over here. So this probably was built here on the shoreline and then just pulled out. So depending on the applications might help you determine the different types of loops that you would go with. Next slide.
Good point, because every situation is a little bit different. You've got to get out there and survey the property and see what's available or what's not available, and then make the best choice for the loops that need to go into the space. A properly sized system has to have a properly sized loop, and that can be done through different types of design systems. Different manufacturers have different programs that will help you with programming and sizing your loop. But again, spacing is key in situations like this one as well. Okay, here we've got another one. This is a vertical loop system that's showing the vertical wells down the middle and then the supply and return lines on both sides. These are great because they take up a lot less room, so your land availability doesn't have to be as large, say as a horizontal loop system where you've got lots of acreage to put in a horizontal loop, but in a lot of situations that's not possible. So a vertical loop system is a great application. And again, as long as it's sized properly for the unit and the loads, it'll do equally as well.
I just want to poke in here and give credit to some of these images are from Geosource Energy on their condo and commercial work jobs. And it's interesting because there's been a lot of development in the last decade in vertical loops installations and some of the technology that they're using for drilling. And this picture here kind of clearly really just want to show that even in really high dense urban applications, this is, in the GTA and it's very dense, and they're putting a condo up here. Angled drilling and deeper boreholes is something that's kind of emerged in the last decade, which allows these boreholes to be put pretty tight together. And I think I have another image coming up later in the presentation that shows the angle that these boreholes are on so that they can basically fit into a small footprint at the surface, but then extend out horizontally beneath the surface, allowing more capacity to be installed in a smaller area. So you can see that in these condo applications, they come in there before the building is put up, and then building goes up over top of it. This one here was actually, I think this is Kitchener area here. So lots of development there, and that's certainly fueling the opportunities in the Toronto GTA condo area.
Also in that middle slide there that you can't see, with the vertical bore especially, you definitely need to grout, because one thing you don't want to have is airspace or pockets in that vertical bore. Everything's got to be tight around the loop to have proper heat transfer, so you can get the BTUs that you need for the unit to supply the heating and air conditioning for the space. So grouting is key.
Very, very good point. Okay, so I'm just going to explore a bit of an example of an application, residential. I mean, we're sticking mostly to residential in this conversation. And this graphic here is from one of the manufacturers. Water Furnace has a data monitoring system as an option in their equipment. I believe it's called the Symphony system. So it does a really cool job of recording data so you can analyze it after the fact. So this is real-time data that was collected. It's a little bit older now. I've used this in previous presentations, but from December 2019. This was a 3-ton, if I remember correctly, this house was a new build and they did a 3-ton vertical loop. And this house was a pretty energy efficient new build. So just to highlight here, yeah, this was December 19th, so fairly early in the winter season. We can see the loop entering water temperature from the loop coming in about 8-9 degrees Celsius, and then going back out about 6 degrees Celsius. So we got a bit of a temperature difference there. On this particular day, the outdoor air temperature was minus 15 Celsius, and the load or the output from the heat pump itself was about 22,000 BTUs. And this is a 3-ton ground source heat pump. And I believe, 2-stage heat pump. So here we can get from the coldest day on the year, coldest day here. This isn't the coldest day of the year, but this is minus 15. We were running a COP of 4.5. So that's a pretty incredible performance figure right there. If we move to a little bit later in the wintertime, now I believe this was the coldest day in that area. So minus 19 degrees Celsius on February 28th. So later in the wintertime, what's happened to the loop? Well, the loop temperatures have now come down because we've been extracting heat from them for the last couple of months. So there's still our temperature difference there, outdoor air temp, and then the output from the heat pump. And again, our COP is performing quite well at 4.7. Now, if we fast forward that to the summertime, to see what's going on in cooling. So we've gone through the winter, and now we've probably done a little bit of cooling since May. So our loop temperature is again back up to 15 degrees Celsius. We've got a decent temperature difference there. And I think this was probably one of the warmer days of the year, 29 degrees Celsius. And the important number here is the ER is 30.5, which is pretty incredible. So we're going to talk a little bit more about those numbers as we get later on in the presentation when we look at air source heat pumps comparative. But these have major impacts on at scale adoption on grids, electricity grids. And that's one of the major benefits of ground source heat pump adoption. It's also interesting to note that we have to think about these ground loops kind of as thermal batteries. They're seasonal storage. So we're rejecting heat to these ground loops in the summertime, and much of that heat is being stored and then reused in the winter heating season. So it's an annual cycle of heating and cooling. Okay, Ron, did you want to, oops, sorry. I'll let you go into a bit of a talk on equipment that's on the market.
Yep. Thank you, Jeff. Yeah, there's, when it comes to putting a geothermal system in a space, there's always, there's maybe multiple options, but there's always typically one best system that suits the space best, matched up with the properly sized loop. And so there's different systems, as you can see here. There's some compact units, some horizontal units, vertical units. There's some water to water. There is some combination and triple function units available that can do some shared heating, in-floor or radiant type heating as well, and some air conditioning. So the choice of equipment is key, and your contractor, it's always best to have a real good, candid conversation dealing with your contractor who knows what they're doing. And there's some fantastic contractors out there. You just have to find the right one that's going to work best for you, and put in the best piece of equipment that's going to keep your family, your space comfortable year round. So you can see some choices of different types of geothermal systems that will do well in the house or office or commercial spaces, what have you. But yeah, there's some great manufacturers out there. But yeah, just do some homework. Make sure you get a credible installer who's got some credentials, who maybe can show you or tell you about some projects that they've done in the past. Give you some references possibly. But yeah, this is an investment, so you want to make sure that you're putting your money, and it's going to last. We typically tell people that geothermal units should last 20 to 30 years, and I know that there's some out there that are longer than that. So when you properly design it, properly install it, the likelihood is that you're going to have a great experience with the geothermal system, whether it be, a water-to-water system or a forced air system.
One of the trends that I've been seeing here in the equipment space is just improving on efficiency of the existing systems and feature laden. More features are coming into these boxes than they've ever had before. We showed an example of the Symphony system from Water Furnace. Most manufacturers are now getting on to data acquisition, data monitoring systems to allow the homeowner or the building owner to get an understanding, really show them, how much energy am I actually getting from this ground loop. And then also features that are friendly for the contractor. Heat pumps are changing quite a bit from 10, 15 years ago. They're getting smaller, so they're able to pack in more performance and more capacity in a smaller, lighter box, which is great. And which is also, it also kind of plays into, if you're in the commercial world and you're doing retrofits of schools, small horizontal equipment, most manufacturers have some really tiny units that can get in there and match up. And then the other interesting thing is just high temperature with I'm trying to think of the technology. It's escape me. Vapor injection compressors. That's it. So now we're able to get into higher temperatures, 140, 150 degree leaving water temperatures from some of these water-to-water units that can provide dedicated domestic hot water in these systems. And then also you have manufacturers coming out with fully variable speed compressors in, whether it be forced air systems, triple function, or water-to-water systems. So the tech is definitely improving, and obviously there's going to be more changes to come as refrigerant policies change, and we need to adapt to new refrigerants. So manufacturers will be on the ball for that. But more features, better efficiencies, better performance, better capacities, lighter boxes. Kind of what I've been seeing.
Yeah, to your point,
Okay.
Jeff, equipment has changed so much over the years where, the COP numbers that we used to talk about back in the day was, if a piece of equipment had a COP of 3, that was a fantastic unit. But now there's a lot of equipment choices out there where you've got, well and above beyond that, where we're talking between 4 and 5 and above. So just helps your investment and pay it off that much sooner. In this slide, here's just a few, as it says, tools of the trade, things that contractors would need to do an installation. You can see some different charging stations there. They're great because the thing that you want to make sure is that you get all of the air that's out of the loop. Because you remember, when you're putting the pipe in the ground, it's full of air. Now you're going to change that to 100% water and ethanol or methanol or something, or glycol. So you want to make sure that the air has been discharged. Micro bubbles sometimes happens, and that at some point in the future they can cavitate and come into a collection and cause a nuisance service call down the road. But flushing the loop is key. Let it run for a while, make sure that all the air is out, pressure test it, make sure the water level doesn't go down when you're deadheading it, so you've got the air out. Some of the equipment that's needed to put the loops together, this fusion equipment. There's some tools there for socket fusion. There's couplings and different pieces, cutters and whatnot. But having somebody that's been through some training on putting loops together to make sure, you want to put this loop in the ground one time and not have to dig it up because there's a loop. I'm not saying it doesn't happen. It does on the rare occasion, but you want to give the best possible chance for that loop to work effectively as possible without having to come back to it at some point in the future. So having the proper tools is key as well. And there's some pressure and temperature gauges, for checking things out, making sure your loop is pressurized properly. Some loops, there's a lot of contractors that put in non-pressurized systems. So that's a little bit different than a pressurized system. So there's different tools for different types of loop choices. So it is key. You want to make sure that your service truck is well equipped with everything you need to go in and do the job, because we all know that unnecessary return visits just cost some money and some nuisance and some headaches. So have the proper tools available on your truck, and this just depicts some of them that you're going to need.
Yeah, I think I'll just add in, like, there's some, depending on where you are in Canada, across the country, there are some great distributors of equipment, tools, and all of that. And most of the distributors that are, if not all of them, that are engaged into geothermal are providing training and support because, making a transition from, say, installing gas furnaces and ACs into geothermal. I mean, we're providing the homeowner's energy system, right? That piping loop in the ground is their energy system. So it takes a little bit of a different skill set, maybe some time to learn it. And for example, like these flush carts, they'll only flush a certain amount of piping, right? So and in a certain way, we have to make sure that the flush cart has enough power to force air out of the system. And so that means that when we're designing the ground heat exchanger, it needs to be designed in such a way that utilizing what we call a step down header to ensure that the velocity of the fluid flow when we're using this flush cart is high enough that those micro bubbles are forced out. Because I can tell you, if the flushing process isn't done properly, it does become a nuisance challenge. And sometimes, air bubbles can be deceiving and cause different faults that can sometimes be tough to troubleshoot and diagnose. So flushing is utmost importance, but also the design of the ground heat exchanger to suit the flushing process is very important. So, and like I said, lots of great distributors across the country that provide full service training and support.
One thing that we used to do in the past when we were installing is let that flush cart run so that you can be working on some other parts of the project at the same time simultaneously. The longer you can let that flush cart run, it is getting more of the pockets of air and the micro bubbles out of the system, and hopefully lessening your chance of having to come back for a nuisance service call just because there's a little bit of air. It does happen, but the longer you can let that run before you tidy things up and leave, the better.
Yeah, excellent. And then on the fusion side, it can be a little bit deceiving if you haven't done fusion before. Your intuition is to twist the pipe and try and get it onto the tools while twisting it, and that would be a big no-no. So having a distributor around or those folks that have already done fusion to walk you through those simple little training notes really helps make the process that much easier. Okay, so I'm just going to talk very briefly here. Like, obviously, economics plays a big role in ground source heat pumps. For those of us that are working in the residential field, consumers and building owners need to see a reasonable rate of return on their investment. Otherwise, it's not going to make sense for them to incorporate it into their house or building. Now, we have some advantages today, as we've just, the federal government just recently announced the Canada Greener Homes Grant, which geothermal is listed on there for both new and replacement systems. So a new system would get a $5,000 rebate, and a replacement of an existing geothermal heat pump, I believe, is a $3,000 rebate. Now, part of that process, if you're not familiar, is the energy audit, building energy analysis process through an EnerGuide evaluator that would come through and do an analysis on the building, do the report, and then the homeowner is responsible to do the work that they're going to do to improve the home. And then the advisor comes back and does a second assessment to say, okay, well, here's the work that's been done, and now here's how the home looks today. And so the Greener Homes Grant does cover the cost of that evaluation as well, which I believe is about $600. So when you factor that into it and you look at it, rural retrofits has been probably the most economically viable installations for a while now, and that's because delivered fuels are pretty expensive as compared to natural gas prices in urban areas, plus the economics of the system when you're not having to, bring in specialized drilling equipment like vertical drilling. the upfront costs are a little bit lower. And if you look across Canada, certainly in Ontario, I have the Ontario numbers kind of in my head. I think there's still something like 250,000 oil furnaces in operation in Canada, a couple 100,000 electric resistance systems, in Ontario. So, and I know in various parts of Canada, that's going to be the same thing as well. So there are some real strong opportunities in rural residential applications for those retrofits. Vertically in urban areas, and here's that image again of what I showed you. There's been a lot of development in the condo world, some really innovative business models that are taking the capital cost kind of out of the picture for building owners. And those companies essentially offer full design, installation, and utility type operation of these systems for condo owners, condo boards. And so they can take that capital cost between the capital cost of the ground heat exchanger out of the picture. Because when you look at a condo building that's on a conventional system, let's say it's on a boiler with a chiller cooling tower versus a geothermal loop, well, the equipment in the building is pretty typical. It's pretty much the same. You either have heat pumps in the suite or you have fan coils, right? So the system, the dynamics of what's happening on the inside of the building are basically the same. The big difference is the ground heat exchanger. So if you can remove that cost of installation of the ground heat exchanger and take that risk out of there for the owner, it makes it that much more viable. The second thing is, and which is interesting, what we're seeing in different parts of the country is municipal standards and municipal green building codes are really driving the adoption at the local level. And the Toronto Green Standard is a great example of that, which I believe in the last 2 weeks, they just approved the version 4 of the Toronto Green Standard, which I guess is ratcheting up that standard to the next level next year. And so those are putting tighter and tighter controls on developers that are building such buildings to ensure the energy efficiency continues to improve. And so much so that by the time you reach 2030 or perhaps just before, you probably won't see new gas installations in new buildings in those municipalities with these green building standards. And I think Vancouver is also an example of such, where I think their standard is moving ahead basically next year. I believe they just voted on that. So no new gas next year. So a lot of municipalities are building these standards right now because of their climate action targets and their climate plans. And they're really setting 2030 as a pillar target point on the way to 2050. So there's some lofty goals there, and really ground source heat pumps helps those municipalities get there. So one of the things we talked about earlier on, what are we doing on time? Okay, 20 minutes. So one of the things we talked about earlier was, and I see somebody ask the question of COP. What is COP? Coefficient of performance. It's basically how efficient the operation of the heat pump is compared to how much energy we're putting in. So how much energy are we getting out of this thing for how much energy we're putting in? And why are we going through all the trouble of a ground heat exchanger as compared to, say, an electric resistance heater that's 100% efficient, right? You plug in a resistance heater into the wall, you get 1 watt or 1 kilowatt of energy from the grid. You get 1 watt or 1 kilowatt worth of heat into the house, right? That's 100% efficiency. While we're plugging our ground source heat pump into the earth and we're getting free watts from the ground. So that's giving us 1 watt from the grid to power our process of the heat pump. And the heat pump process is really just moving energy from the ground into the house and vice versa. And so that's where we saw those high COPs of 4, 4.5, even up to 5 in some situations. And that means a lot to us at a societal scale, which is, this is coming from the Dunsky study that we mentioned early on, because we're obviously making a shift to electrified space conditioning. It seems pretty clear that heat pumps offer a great solution to decarbonize our building stock. And most of the energy we use in our buildings is for space conditioning and water heating. So the challenge becomes is what types of heat pumps do we use? And I think it's important that we look at, air source heat pumps are a great option, and they're going to play a major role in a decarbonization of our space conditioning and water heating. But it's important to note that, the days that you need the energy the most and you need the most efficiency are the days that the outdoor, the air source heat pumps are least efficient. So peak heating and peak cooling is when these systems don't perform as well as they could. The performance obviously has been increasing over the years as the improving compressor technologies and cold climate air source heat pumps. And so as you can see in these charts here, when we get to -10, we're still, a COP of 1, above 1, 1.5. And that has a major impact at scale on the grid. And so this is the real benefit of ground source heat pumps. As you can see here at the bottom, the power consumption of a ground source heat pump system as compared to an air source heat pump system. So there's a considerable gap between that. And that gap can make up a tremendous amount of cost when we're talking about, $1.4 trillion to electrify our space conditioning systems. This gap can represent a major impact on those costs. And okay, so next, I just want to take a quick look at where we're at today in ground source heat pumps, because if you're not familiar, if you're a contractor, you're not too familiar with ground source, or you haven't gotten into it yet, well, it's perhaps not a surprise because we don't represent that much of the market. And unfortunately, statistics specifically on ground source heat pumps in Canada don't really exist in a central database. HREI doesn't track shipments specifically of ground source heat pumps. But essentially, the National Energy Use Database says about 5% of homes were using heat pumps in general in space conditioning in 2017. So let's say that's under 800,000 homes of 15.5 million, I think, private residences in Canada. So it's probably coming up since then. That was 2017 with more and more air source heat pumps, very likely. But from industry statistics, we're probably talking about 5,000 or so ground source heat pumps sold nationally last year. That may have been 2019, I think. And most of that going into custom new construction. So the market is relatively small. I'm guessing that's like 1% or so of the space heating market in Canada. So that just means that there's a lot of room to grow. There's a lot of work to do and a lot of room to grow. Now, opportunities that are really showing some optimism. We talked a little bit about it, but also in the MUSH sector. So campus type applications, schools, high schools, community colleges, hospitals. So larger installations with large loads and potentially large areas for ground loop installations, like soccer fields and university campuses. They usually have a fair amount of land area to put these systems in, are really see an economic benefit from the installation of these systems. And also in the case where I think a lot of what's happening here is energy services companies, ESCOs, that will take up that capital cost, and essentially the building owners or the schools will pay that project cost off with the savings that they have or the difference in their energy bills over the course of a number of years. So there are interesting financial models in those segments like there are in condo markets as well. So the multi-residential, and that's what's serving to help grow the growth there. We're seeing those community scale developments in residential single family start to prop up those district type systems, or in just single, we've seen a bunch of single loop, single house in communities as well. There are different considerations that come with the type of system, like the Markham project, I think is operated by Enwave. And so you have a central operator and a district type system that is responsible for, the pump house, if there's boiler backup, operation of those common loops there. Whereas if you go with a single bore, single house, the operation is a little bit simplified, but you don't get the benefit of economies of scale there and sharing of thermal loads and that sort of thing. So And then just to speak to the last point here, I think there's something like 500 or so municipalities across Canada that have declared climate emergencies, and they've all been working hard on their climate action plans. And for most of those municipalities, they're looking at, okay, well, where are our emissions coming from? Probably transportation is number one, and number two or number three, depending on the makeup of the municipality, it could be industrial, but then buildings, right? So buildings represent a big chunk of their municipal emissions. And so that's where the heat pump solution is coming into play there. And just the thing, what I really wanted to highlight from this presentation is the impact that ground source heat pumps will have, because I think across the country, the default is to, when we're saying heat pumps, the default is kind of air source heat pumps, right? That's simple. It takes care of, and I've literally heard this myself. You know, I've installed it in my house and it's great. And it's kind of a bit of a challenge of the commons, because it does work great for the individual house, and the individual homeowner or building owner feels that benefit immediately. But the problem becomes at scale is, you know, we need to figure this out at scale to keep those costs down from a societal perspective of grid expansion, right? So that's where geothermal can really play a major role. Now, to show that example, just check my time here. 12:40. Okay, we're good. So just show that example. Sweden is a really good example. They had in the late 80s, early 90s identified, I think they were primarily using a lot of oil for their space conditioning system. So they really had, with energy costs, they really had to make a change. And so they underwent the transformation that potentially that we're kind of looking at. And you can see the market adoption rates of ground source heat pumps over the couple of decades that they were working on it. And, you know, they worked on different incentive programs, different policies to help induce geothermal across the country. And it seems to have worked most of all. But what you're seeing there is a mix later on in the chart. You know, they start to see more cold climate air source heat pumps, and then air to water heat pumps come into the mix a little bit more. And certainly that's okay, just as long as we have a good chunk of ground source heat pumps in there to help that portfolio perform. And this image, for the contractors and for the folks on the call that, you know, think that it might not be possible in dense urban areas to do this, these are all single drilled vertical loops. What town is that? I can't pronounce that right. So Sundyberg. These are all vertical loops installed for houses and buildings that are independent. So they're not common, and they're all in pretty dense areas. So the technology is there to get these loops installed in small areas, and the benefit would certainly be there as well. And here's the benefit. I have to keep moving this here. Here's the benefit: a reduction in this is their heating oil use. So they totally got off of heating oil, which was their objective. And of course, with that came along is their greenhouse gas emissions reductions, which is the same thing that we're looking to do as well. So major impact of heat pumps, ground source heat pumps in Sweden. And so that's, I think we're at 12:48, which is a good time, I think, to put a hold on it. So that's our presentation. Thank you very much. And let's open it up to Loretta and questions and all of that.
Yeah, absolutely. I have quite a few, so I'll just read them out. How does, some of these were a little bit earlier on, so you might have addressed it already, but I'm just going to ask them in any case. How does this affect the frost line with pulling the heat out of the ground in the winter, more in the community setup? I think this was way early in your session. So.
Yeah.
That's a very good question, because that does get mentioned. Because as you're pulling heat out of the ground, that does pull the frost down. So it wasn't uncommon years ago to bury loops about 4 feet in the ground. That has literally gone by the wayside, and you really need to get well below the frost line. So I'll say horizontally speaking, and when you're putting the headers in for vertical loops, you need to get at least, you know, like I mentioned, 6 to 8 feet below ground level. And then you should be well protected. As the frost comes down, you've still got lots of soil space there to get your ample heat transfer.
Okay.
Good question.
Okay. I have another question here. Somebody wants the name of the company that you mentioned in Stratford. I think it was a.
Oh, yeah, it was certainly, I think they're on the call, Buchanan and Hall.
Oh, okay. Oh, okay. Sorry.
I'm just using them as one. I mean, I
As an
live near the
example.
Stratford area, so that, and I know they have a really cool fleet of directional drillers. So yeah.
Oh, okay. Okay. I have another one here. In your 3-ton example, how much backup
Yeah.
was required as your outlet?
Yeah. I can't. I don't actually have that data, but I know that was a super tight house. So typically, I mean, I guess I can answer that. We obviously want to minimize that backup here because we want those heat pumps running at peak condition. We don't want to be switching over to an electric heater. So that all comes down to our sizing and capacity of that heat pump. And manufacturers will provide software, energy analysis software, so that we can understand on an annual basis and on a peak basis when the compressor is running and when it's not. But from a backup sense, usually, you're going to be less than a couple percentage of the year would the electric heater be running on a decent design. Now, you can make it such that the electric heater doesn't have to run at all for heating. You can size it in that way, but the economics start to get a little more difficult because now you're adding in more source, so more geothermal loop to meet that load, right? So a lot of the times it makes more economic sense there just to size it such that heater does turn on for a couple percent of the year.
That's actually a real good question, because in the grand scheme of things, when you're putting a loop in the ground, the pipe is cheap. You put that in once, as opposed to if you undersize the unit and or the loop, you're paying for extra auxiliary heat, year after year. So that's where it gets expensive. So as we mentioned, properly sized loops is key to make sure that you're getting the best amount of BTUs out of the ground as opposed to from an electric heater.
Okay. I have a couple more questions here. We had a question that says, what type of pipe is shown here? And they're referring to the horizontal trench on the acreage.
So, I mean, all the geothermal loops are a grade of high density polyethylene. I think most times these days it's 4710. So, I mean, frankly, it's very similar to gas pipe, but yeah, high density polyethylene.
Okay. Can you go over the piping costs associated with loops?
The pumping costs is that, yeah. So as we get into higher efficiency mechanical systems, we're using small circulators on residential closed loop applications, and more we're seeing variable speed technology come into those pumping systems, which is really gives you the ability to really dial in the amperage of the pump system to what you actually need. So you're only delivering the flow to get the energy that you actually need at that time, load matching, right? So pumping costs, only thing I can say to that is it is a important part of the design, because we want to make sure that when we're designing that ground heat exchanger, that our pump watts are as low as possible. There is such a thing as an inefficient piping system. It's not as simple as just melting some pipe together in a couple of lengths or whatever. We have to be considerate of pressure drop and pumping watts. So I'm hoping I'm addressing that, Mike.
Okay.
Yeah.
I have 2 more questions here. How deep are these vertical boreholes? There's a worry of the impact on the water table, and is this a legitimate concern?
Yeah, it is a legitimate concern, but I think it's an education thing, and we're actually going through that right now. The OGA is working with TAF, the Atmospheric Fund, to develop a drilling guideline standard, because as municipalities are looking at this, and I'll use the region of Waterloo in particular, because Waterloo sits on a heck of a lot of water, and they have the drinking water aquifer. I forget at what depth, and then below that they have like another aquifer, which is like a brackish water. And so obviously when you're drilling, you could be drilling through the first aquifer and then into this brackish water, right? And you don't want cross contamination there. So this can be done safely and properly, and the grouting process is integral and key to this process. So it's an education on drillers know how to do this for the most part. In those vertical drilling angled applications now, I think they're getting up to about 850 feet of depth when they're drilling. So they're going pretty deep. But it's an education process for the municipalities to understand how these drillers are addressing the concerns and doing this properly. And the OGA is helping build some drilling guidelines to help that process.
Okay. What is the required depth of a vertical line? Or
That's
did I ask?
That's a real good question. There's no real set guideline. Certainly, I guess the easy answer is the number of holes the deeper you go, cuts down the number of holes you have to drill and cuts down the amount of space. But when you get into different programs from different manufacturers, you can actually design this out in a system so that you've got everything kind of keyed together. The loop matches the flow center that you need to provide proper flow for the unit to the BTUs required in the space. But as Jeff mentioned, some get down 800 feet. For residential purposes, 100 feet, 200 feet is probably a decent average, although I know that there's some that are deeper. But yeah, that's a good question. But also mentioned grouting these afterwards is very key.
Okay, I have one more question. If an existing building is on a hill, what are the installation obstacles?
Well, there's two types of systems when you're looking at closed loop and not closed loop, pressurized and non-pressurized. If you're looking at a non-pressurized system, that can be a problem if your water load is above where your pumping station is for this non-pressurized system. As far as a closed loop system, there really isn't any adverse effects going up a hill, so to speak. If your house is say built on a hill, your properly sized flow center would be able to look after that.
Okay, actually, I just had one more question that just popped in. In Oakville, we have had previous issues with methane and ground gases, which end up in requiring other agencies to be involved. Is this something which is typically seen elsewhere?
So I think that in Oakville, I think that kind of spurred the process, the environmental compliance process, ECAs that drillers are required to carry to do their process, to do their drilling. And I think there's different regulations and different protocols in different municipalities. So that's really what we're trying to help with the drilling guideline, is create some standardization around that and give municipalities a guideline and how to understand drilling properly in their regions or in their municipalities. So I don't think obviously what was seen in Oakville kind of spurred a lot of interest there, and that was particular to Oakville. So they vary from municipality to municipality, but that certainly kicked off an environmental process to make sure that we're doing this properly. And there are ways to do that.
Okay, great then. I think that's all of our questions. I want to thank both Ron and Jeff for taking the time out to educate us on Geo 101. We also have another session that will be coming up. Jeff, did you want to just talk a little bit about that one that we're going to be doing in August?
Yeah, I think, do we have it scheduled for August already? That's,
yep.
Yep. Okay. I think it's more of the idea is more of a business analysis. So we want to get some contractors that are already into the geothermal business to talk about a little bit about their journeys. And so for contractors that are looking at getting into it as part of their business, more on the, sales, marketing, the business side of things. So
yep.
That's what
and if anyone is on the line right now that would like to participate in that as an attendee or even as a presenter, feel free to reach out to myself or Jeff. We'll also be sending out a survey to everyone. And if you could fill that out, that helps us identify other sessions that we could put on, and we really do appreciate your feedback. With that, thank you, Ron. Thank you, Jeff. And everybody have a great day.
Thank you very much, everybody.
No problem.